Hello boys and girls, here we are looking at lesson 11-7 on page 389 of the math journal. And we are going to work with surface area. When we talk about the surface area of any prism, rectangular, triangular, cube, any prism, and we talk about the surface area, we are talking about every surface. They will each be added together. Okay, so you will find the area to every face. So here we have this face, the front face, but then we have the other one that's on the back. You can't see it, but it's like this. It's in the back. And then you have the right side face, but you also have the left side on this side. And you have the top face, but you also have the bottom face, which will be exactly the same. When we talk about surface areas, we will find the area to each face and add them all together. So as you can see here on the right side, we have area of the front. Well, find this area, area of the back, area of the right side, area of the left side, area of the top and the bottom. And then you work your way down and add them all to get the complete surface area. Since we have not been given any dimensions, please use the following dimensions. The height will be 9 inches. The length is 17 inches. And the width, 11 inches. After you solve each face, so any rectangular prism or cube will have 6 faces. 1, 2, 3, 4, 5, 6. You must add them all together and you will get the surface area. Now, for you to know that you have the right answer, you must have the answer 878 inches square. So go ahead and find all of these, add them up, and if they add up to 878, you have the correct area of each face. Continuing on, number 2, they want you to think of how to find the area of a can. Okay, where you have to find, for example, the top of the can, which is a circle, the cylinder, and the bottom circle. Well, if you can find the top circle, you can multiply it by 2 to get the bottom circle. And then the cylinder part. Well, we've talked about cutting it and opening it, laying it out so that we have a rectangle. Okay? Well, let's say the height of this is 10 centimeters. What would be, so this would be 10 centimeters, which is also this. Then what would be the length along the bottom? What would be the length? Well, if you can find the circumference to the circle, because we've cut it open, it'll also be the length. Well, you need to find the area. So first, measure the diameter of the can. The diameter, the length across, the distance across, diameter, and divide by 2 to find the radius. Then calculate the area using the formula. You can tell I'm having issues with autocorrect. So calculate the area using the formula. Area equals pi times radius squared. Right here. Okay, once you have that, you're going to have the top. You multiply it by 2 so that you can also have the bottom. And then you need to solve for the circumference. The circumference is pi times diameter, which will give you the length. Please copy this down exactly as you see it. Question B, how would you find the area of the curved surface between the top and the bottom? The curved surface, they're talking about the actual cylinder part, the body of the can, the cylinder. Okay? So, as we mentioned, calculate the circumference of the base, okay, or the top, the circumference of the base or the top, by simply solving the circumference. Circumference equals pi times diameter. That'll give you exactly the length around okay, which is also this. Once you open it, and multiply that by the height. So once you have this, you multiply by the height, and that'll give you your area. Again, pause the video here to copy this exactly down. If you do have any questions or something doesn't seem clear to you, make sure to ask tomorrow in class when we check all these pages. For question C, you are asked to choose a can, any can. Look in your cupboards, get a can out, any can of food, tomato paste, tuna, anything. Find the total area of the metal used to manufacture the can. So you're going to look for the top, the bottom, and the actual cylinder. And remember to include a unit for each area. So I would recommend using a ruler with centimeters. First, measure the diameter so that you can calculate the radius and you can find the area of the top. The area of the bottom, if it's a perfectly cylinder can, it should be the same as the top. And then the area of the curved. Now this is going to be difficult. Not so much though. Remember to find the circumference first. And once you find the circumference, you will multiply it by the height of the can. And then add them all up and you will have the complete surface area. Here you have the formulas that you will need to find the area of the top, which is the same as the area of the bottom. Area pi equals pi times radius squared. And then to find the area of the what they call the curved side, which I'm calling the cylinder, the long part, the body, okay, you first need to find the circumference. So diameter, use the diameter times pi, and then once you have that, multiply the circumference times the height of the can to find the area of the cylinder. I just made a new acronym there, area of a circle. Once you have these answers, add it up. Continuing with surface area on the next page, 390, we have to use a ruler and use the inches to find the dimensions for the triangle and for the rectangular faces, and then solve for the area. This is something you are all familiar with the exception that we are now working with perhaps decimals or fractions, whichever you feel most comfortable working with. Don't forget that you must half the base times the height for the triangle, and for this one it's just simply length times width. Okay? Once you have found this, boys and girls, you're going to combine this area with this area to make a triangular prism. A triangular prism looks like this. We take our triangle, okay, and then we take our rectangle, but we're going to need 3 of them, one for each side, and we're going to put them, that's 1, okay, and then there's one in the back that goes like this, okay, and then along the bottom. So there's 3 of them. This would be, the one that we just drew is 1. The one in the back side is 2, right here. And then the bottom one is 3. Okay, so there are 3 of these. And how many of these? If you said 2, 1, 2, you are correct. So once you solve this, okay, you make sure you add it up, or actually here you have 2 triangular bases and 3 rectangular sides, as we just mentioned. Add them up so that you get the total surface area. Just the same way you did number 3 with the triangular prism, you will do number 4, but this time with the square pyramid. So with the square pyramid, this is the base. Okay, square pyramid, and you're going to have a triangle for each side. So 1 triangle, 2 triangles, 3 triangles, 4 triangles. Okay, so you will not need to find this area, which is only 1 of them, and then find this area, and you'll have to multiply it by 4, then add those numbers to have your result. We will check this page thoroughly next class. On page 390A, we are going to practice analyzing fraction data, which means we are going to look at this data that we have here, okay? We're looking at the length of insects. Okay, for example, an American cockroach is 1 inch, 1 3/8 inches. An ant is only 1/4 of an inch. Okay. A bumblebee is 1.5 inches. Well, so now that you have these stats, okay, or this data, we're going to create a line plot. Okay. Be sure to label it, give it a title. Okay, give it a title, and at the very bottom there's another line. I couldn't get it in the picture. I give it another line to let us know what information we are actually looking at on this line. Okay? So be sure, boys and girls, to find a way to label it well enough. If it were me, I would probably find the half, okay? And I would label that as a half. Okay? Find the quarters. There's the quarters, and label those. This would be 1/4, and this would be 3/4. Okay? You can also find eighths. There's 1/8, okay, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and there's a whole eighth. And you know that you can continue this way as well. Okay? Label the x's. So we'll do this together again in class, but it must be finished for class. And finally, it wouldn't be complete unless we answer some questions about the data we analyzed. So take a look here on page 390B and answer the questions you see using the data from the previous page. What is the maximum length of the insects measured? What is the minimum? What is the range? Mode, most repeated number, the median, the middle number, okay, and so on. We'll check these in class, boys and girls. Do not do the math boxes for this lesson because you do have 4 pages of homework. Math boxes, we will do them in class as a form of formative assessment. See you next class. Alright, and I almost forgot. Back by popular demand, I must include a joke. Some of you have been upset because I have not included a joke in the last couple of lessons. Well, here I don't really have a joke, but I have more of a riddle for you. What's taken before you get it? Your picture. Alright, let's try another one. Why can you never trust an atom? Because they make up everything. Get it? Okay, that's enough for today.